We go back to that TAPO, that design process, guys. That's where you're at right now. You're starting to pick those elements up. You've kind of got a vision for what you want to do, I hope. And if you're pushing that through this assessment, how do I do it? Where do I get the resources? Do I have the money? Do I need to join a community, right? You know, what do I need to do? You know, the biggest step there, reduce your consumption, and you don't have to do a whole lot. That's much easier than trying to do everything. And at that end, I can start to do this conceptual planning, and then I'll finally produce a nice master plan, which is never finished. Yeah? And you can't almost possibly finish it in this class because you're not even at the site where you're going to do it, right? So we're learning the process so that when we get to the opportunity, we'll be ready. Always remember the permaculture principles, the design principles, relative location. Where's things located in relationship to each other? Everything on your design, you should be able to list multiple functions. Multiple elements need to be in your design, not just one. Energy efficient planning, where I locate the elements for my personalized energy. Use biological resources to help you, okay? Plants and animals. Energy cycling, moving energy through our system is what this is about. Use small scale intensive systems, guys. Don't try to do broad scale extensive stuff. You don't get a lot of return for a lot of usage. Accelerate succession. Understand natural succession, and then you can accelerate it. Whether that's me making mushrooms or today accelerating the production of compost. This is us accelerating succession. Create as much diversity in your plan as you can. When you get diversity in ecosystems build resiliency. The more resilient your ecosystem, the less you're needed. And remember functional design, what did it mean? You're not needed. You built a design that became resilient enough for you not to need to manage it. Edge awareness. The edge is where the profit's at, guys. We're going to start that in the garden. When we start to look at our plants and assemblies, it's really easy to focus on that mandala right in the center of the garden, right? But that's not where the profit is. That's easy. Everybody can do that. If you want to get better than the average, you're going to have to work on the edge, okay? Edge of everything. And that's when you start to see, wow, look at the edges. And your attitudinal principles. You've got to have a good attitude. You need to start to see the problem as a solution. That's an attitude, okay? We don't see negativity. The world isn't going to end, guys. I'm just telling you, it isn't. It's been going on for 4 billion years. It's not ending anytime soon. Okay? We may not be here, has nothing to do with the world ending. Okay? And the next little species of monkeys will come up and do whatever they want to do. But while we're here, we have the opportunity to do our part and do it in a positive manner. So permaculture helps us to be positive about our little time space. I can do what I can, I do the best I can with what I have. And the first step, just use less, makes life simple. So problems to solution, work with rather than against glacier, least change and protracted and thoughtful observation. So step back, think about what you're going to do before you do it, and that will make you not do thoughtless labor and have to do things over and over again, which waste your time, your energy, and your money. So permaculture in commerce, what does this mean? Well, one way to look at, and you know guys, y'all been living with me for a while, I like my beer. So if I'm going to make beer, and I think about the supply chain of the typical beer production, it's not very good. They make waste. They take the spent grains, they throw them away. Some people like put them in landfills. It's not a very good production process. But if it was a more so of a permaculture process, so on the right we have grains that make beer. They utilize water. They create wastewater that goes into rivers. The spent grains they use as animal feeds or even put in landfills. That's it. But on the other side, I could look at making beer. So I have grains, I can make beer. I can take the water, the wastewater from the pigs is not wastewater. It can be, from the beer, it could be fed to pigs. They would drink it happily. It's not alcoholic. So at that point, I could take spent grains and make bread. Welcome to Germany. Yeah, great breads. So why do we throw that in the garbage or feed it to an animal cycle when we could eat it ourselves? After that, we could take spent grains, make mushroom substrate, so I could grow mushrooms. The mushroom, the spent substrate, after I make the mushrooms, can be fed to a pig. But first I eat, then the animal system eats. You know what? It kind of makes sense, right? We get first, they get second. And then the waste from the pigs could go to a digester. The digester can make methane for my home. I can take that biomethane, put it onto my garden to grow my vegetables. I could grow shallow algae ponds. I could use the algae from the ponds to feed to fish. I could use the fish waste from the pond to put onto my garden. And the circle keeps going, right? We keep linking these things up as much as we can. So ours is a much more input-output, long chains, systems utilizing sun for as long as we can. And theirs is very short supply chains. And short supply chains create waste because they just say, put it in the garbage. So cool. Relative location, make your interrelationships. You need to homework assignment number 2. I want you to take your elements that you've started to list. I might like to have this. I might like to have this. Start to do your needs. What does that element need? I like to call that the inputs. What needs to go into that element? The outputs are its products, and then any characteristics that you may want to describe that particular element. Once we have our elements, we understand their needs and their outputs, then we can start to try to focus more on interrelationships. When you do this, you'll start to notice that the output of this one is actually the input of that one. That's how I make the connection. So the output of a chicken is the input of my compost. I need manure, right? Oh, cool. So now I have chicken tied to manure. Manure tied to compost, right? Compost tied to garden, vegetables. Vegetables tied to kitchen. Kitchen waste tied to worms, right? Worms could be tied back to my fish farm. I could feed worms to the fish in the permaponics if I wanted. And then the fish waste is the input for the food system, which goes back to the kitchen, and then the waste comes back again, so nothing goes out. Where's the waste? It just keeps getting shoved back into the next system. There's no waste. So multiple functions for every element. Take an element. For instance, I have a mulberry tree. It's a great tree. It's a bush, so any berry. It can create shade. I could utilize that tree to shade some other tree that may not like so much light. It can provide food source, food for me, also for, say, chickens. It has a nutrient absorber. For instance, if I have my chicken free range and they're at their house and that their waste is obviously they defecate on the ground, and that tree can absorb the nutrient to create me more mulberries. It has protection. The chicken can jump into the tree to get away from, say, a fox or something like that. And the tree builds soil by dropping leaf litter, so I can utilize it in my composting. So I start to see an element, just that single tree, in multiple functions. Now the products of a mulberry I still didn't describe. I described characteristics. Products would be the mulberry. I can use it, I can eat it fresh, I can squeeze it into juice, I can make it into wine, I can dehydrate it as a berry to use in my muesli. I can then take the leaves, right? I can make tea. When I do the pruning to increase the mulberry, I can take the whips or prunings, bring it to my goat farm. I feed it to the goats. The goats will strip off the bark, convert that into flesh, milk, goat milk. Goat milk, I can make cheese. I take the goat droppings from the goats and I bring it back to feed the mulberries. The output is my cheese. Great. This is the type of thinking we want to proliferate. Energy efficient planning. I start to make a system, right? Here's my chicken house. This chicken house is on a slight slope. That's cool. That means that the chicken obviously can walk up into the roost. The manure can fall out. It's easy to gather. I don't have to go into the chicken house to gather the manure. The egg box is at an ergonomic level. The chicken is happy to go into the box. He affords him protection. I take out the eggs without going into the chicken house. Everything's nice and easy. This is an energy efficient planning, and we can even go further on other systems. So, zoning. Place elements in your design based on the intensity of your use. Remember, here's our house. The elements I use every day, like my kitchen garden, things I'm going to interact with daily, I put very close to my door. Things that I'm going to use less, I put further away. I don't need to interact with them. If I don't go to see them, it's okay. The pond's not going to go away. I don't need to go check on it. So the pond can be further away, you know. I've got ponds on the property that are so, like, way in the back. I haven't gone and walked actually on the Raktamachat wetlands in over 2 years. It doesn't need me. I know it's there. I know it works. It's a wetlands. I mean, what am I supposed to do? I just haven't been there. But that's okay. I'm confident that it does its job. So these are things. So zoning, I've got a nice plan. There's my plan, color codes. Each of those colors, zone 1, the intensive, that's the red zone there, intensive growing and living area. Zone 2, food forest. Also, on the other side, because sometimes zones aren't connected. There's a zone 2 here and a zone 2 here on each side of the house. Zones are not concentric circles. They just fit within. So zone 2 there is a fruit trees on the right. Then they have a zone 3, which is an integrated orchard with a poultry run. So they have chicken tractors in an integrated orchard. And their zone 4 is pastures, right? So they're using pastures to create mulch and fodder. All right, and their zone 5 is a flowering and native area that they don't do anything with. They let it be a native prairie. So that's in their biosphere. They have native prairie, so they want to leave that way, right? So this is a thing, very simply, zone it up. Another take on zones. So this one, a little bit more simplistic, but the house in the center is zone 0. Zone 1 is surrounding the house, and they indicate what's going on there. Zone 2 in that corner, okay, because it's a very small, it's a small house, and they have zone 1 and zone 2. They don't have enough land to have 3s, 4s, and 5s. They don't have big animal systems. They don't have reservoirs. They don't have woodlots. This is more of a, say, urban suburban design. So they go into 1 and 2s. So they'll have their house, garden, say, food forest. Sectors. This is an overlay. There's a house in the center, right? I put a sector around it, and I'm going to now map wild oncoming energies. So which way, basically, does the wind blow throughout the year? Remember to search wind rose. Sun, summer and winter, sun angles. Again, go to your Google Earth, find your location. It doesn't have to be as accurate as on top of your house. It just has to be on top of the city that you live in. At which time, go to suncalc.net. For anybody that doesn't have a computer, you're welcome to use mine. It will fly over. It will overlay the sun angle onto your property. Boom, snag it or snip it and stick it into your design. What about noise? Where's the roads? Pollution, if there's any issues. Any view that you want to maintain, maybe that's an aesthetic view. Any wildlife in your area, have problems with them or they're all okay? And fire. So some wildlife may be a problem, a nuisance, like deers or raccoons, but other wildlife may be like native bees. So I'd like to entice native bees to come to my farm. Okay, what bee trees, for instance, the native bees like this particular type of tree. So if I plant that tree, those bees will come live on my farm and increase the production in my garden. I would do that research if I want to entice that native population. So your sector analysis, or another way of looking at it, same I like to do at compost. There's no right or wrong or right way. We just look at things in different ways. The 4 elements of design analysis: earth, water, air, and fire. So earth, what type of soil types, the soil food web, or land and topography. These are things in permaculture related to earth. Water, what's the availability, the flow, what's your watershed, the top of your land to the bottom, and or containment. Are you going to have ponds, pots, right? How are you going to contain your water? Air, what kind of patterns of airflow? That's wind. Are there any carriers like pollen, things like this that might be in your area? Are any seasonal factors, which could include frost? When's the frost time? What about fire? Fire could be the sun angle and shadow, right? Any microclimates created by sun, and or fire risk. If I'm in Australia or I'm in California, fire would be a risk, as we saw in the Brown compound. That's important that she has to understand her fire risk. Or the solar arc, yeah, of your property. So designer's note, plus any other outside influences of your property, like people or animals, okay, that come in. So people and animals definitely can be construed as a wild energy, right? Think about the Raktamachat design. One of our biggest sections, right, is hippie population control. I thought it was good. No? Oh, man. I try. Getting old. Ha, ha, ha. All right. So we want to use biological resources. Yeah. So a chicken tractor. Now, if you want to build a chicken tractor, let's think about ergonomics. Today we talked about ergonomics with our worms, right? That system is great. It produced us a lot of thing. But then I could, like our wormerator, is going to be a more ergonomically designed system. I'll get a better production with less work. But in this instance, if I have a chicken tractor, I need to be able to move it by myself, not have to get someone to help me. So it should be big enough for you basically, or made of light enough materials for you to move yourself. A very easy way to make one is to take 1/2-inch PVC pipe. So you take a 2x4, you drive nails up, you stick the pipe on, you put another 2x4, you bend the pipe over, it makes the loop, you lay over the netting. Super simple. PVC pipe will bend just like a hula hoop. Yes. Weeding, fertilizing, and or tilling. This is what these things do, the functions. So remember, what is the inputs for the chicken? He needs food. The outputs, this is what he does. Thus we design these biological resource systems. Nitrogen fixing trees and plants are important. We talked about this morning the acacias, how they create compost for us, right, without doing much work. How I can cut them down if I need to create biomass. They create shade, right? They're fixing nitrogen into the soil in long-term cycles. So these are going to be very important trees. We'll talk about that in a lot more detail when we come to the food forest. And here's the bacteria nodules that we were discussing, and there's a picture of them that we were looking at this morning, are asking how did the minerals transfer. So we have our mycelium networks that we'll learn in our mushroom day, and soil science, we'll talk about these nodules in more detail. But what are they? They're basically funguses in the glue of the soil. 90% of the plants have an association with mycorrhizal fungi. Okay? So this is what fixes nitrogen, and what these little white balls are what attaches as bacterial fungal colonies onto the plant, onto the tree roots. There's a symbiosis relationship. They're being given sugars, and they're transferring the, nutrients. We need to look into integrated pest management. We're going to have organic gardening. I don't want to use poisons on my farm. I want to be able to manage my pest in a more integrated manner. So some people walk in the garden and they're like, man, your garden doesn't have any bugs. Our garden has bugs. It does, but they're very limited because we have really good soil. And bugs, a lot of bugs proliferate their egg cycle in the soil. So we have nematodes, worms, potworms, and they're going to eat those eggs. So that helps to break that pest cycle. Also, because our soil's so good, our plants are really healthy, and they can ward off the bug. Every plant can fight a bug, right? That's natural. It's the sick plants that get bugs, and then that sick plant breeds the bugs to go jump on my other plants and beat them down. So keep your plants healthy with healthy soil. Don't have too many bug problems. We can also get beneficial insects to help us out. So we could plant like long-end trees or cosmos in the aster family. These bring in the wasp, wasp beneficial insects that'll come in and eat the, say, bad insects. Like ladybugs are good. I want ladybugs, right? They eat the nematodes. So that gray water. I want to think about how I process my water. It's a very simple kitchen. Look at this, guys. But this is for washing. They just have a big stone slab. Wash your clothes. The gray water goes right to the gravel to the plants. Let's be careful. If we make our own soaps, natural soaps, we're just talking about phosphorus, okay? Phosphorus is NPK, one of the big three. Your plants like it. Besides the fact it's so diluted once we're washing anyway, it's not a big issue. And even for us when we use our soap in the kitchen, every time you've washed since you've been here, that water went straight out to the circles, the Tara circle, and the other one I have a lily circle. But it has salt, so we use salt as a cleaning agent. But it's diluted so much that that amount of salt doesn't hurt the plants. Yeah, sure, if you salt the plant, it'll die, but not in a diluted manner. So cool, very simple solutions. That brings us to the concept of small scale intensive. What does that mean? So these are all the design principles and just showing you, so we're going to move forward into examples. I can see what that means. Well, think about World War II. And there were 20 million victory gardens in 1943 in the United States, and they produced 41% of all the vegetables that were consumed in the United States at that time. At home, people did not buy vegetables, and if we actually went and looked at what those vegetables were, it isn't what's being sold and consumed today by people saying nutrition, okay? And people grew their own vegetables, but it was much different. So we can grow our own foods, but we need to grow what we eat and eat what we grow. So think about what grows easily in your home. Try to adjust your diet to eat what is local. Eat seasonally also. Try to adjust to that. And if not, learn fermentation. Learn how to cook things, right? Make pastas and save your foods over time, okay? Learning to cook will save you a lot of money. Food, not lawns, guys. End of the day, In America, this is a really bad statistic, but it's all over in the Western world. Americans don't really live any more extravagantly than anyone in Europe, nor anyone in England, and nor anyone in Australia, guys. I've been to all the countries. I can tell you it's pretty much the same. We got cars, we got houses. And if you're in a temperate climate, you use a lot more energy because you live in a place that has to be heated because most of the houses are poor and require lots of energy. A house with 2 cars, a dog, and a lawn uses more resources than an energy than a village of 2,000 in Africa. They don't have electricity. So they live, it's warm, they hardly use any energy, and they survive. And we can use more energy than they have access to. So we need to bring that down. We need to start to think about reducing our consumption, building better buildings, bringing that energy curve down. First step, why do we spend so much? We spend 11 billion US dollars a year on lawns in the US. Guys, this is a crazy number. Some small countries don't have GDPs that big. So what if we make food, not lawns? Why are we mowing grass instead of harvesting veg? Yeah, this is kind of dumb. And right now, in lots of places in the United States, you can get grants, and around the world to convert, to make a garden, the government will give you money. Look into it in your own country. Think about diversity and edge awareness. We're going to start to learn in our food forest systems, right? How we can create 3-dimensional spaces and we can create layers. So this is edge awareness. Edge in 3 dimensions, vertical and horizontal, and the edge changes over time, which is called succession. So when we start to build up a 3-dimensional successional awareness of time and space, wow, we start to see nature. So we got to get out of this single plane thought process, which we call monoculture. Monoculture is base. Okay? Permaculture is 3-dimensional. We're going to do that by forest gardening and or food forest. The 7 layers. We're going to understand what each layer is for, how we're going to do each layer, and we're going to do that, the 7 layers of food forest. That makes a designer forest. We're going to put in elements in our forest that are good for us, that we need, being medicine, right? Timbers, right? We can put food, right? We can put habitat for insects, say bees. If we want, these are elements that we would put in to provide for our living. We're going to mimic natural forest, and we're going to create a forest garden. We want to mimic the 7 layers. One, in a natural forest, in that instance, if I drop you off in the middle of the jungle, give you only a knife, and I come back in 2 weeks, you may or may not be alive. Think about it. If I drop you off in a forest out in the middle of Siberia with only a knife, and I come back in 2 weeks, you may or not be alive. It depends on how many YouTube videos of, what's his, what? Wim Hof or Bear Grylls that you've watched. Okay, if you haven't watched them, you might be in trouble. But a forest might be frozen. Yeah. Siberia. There you go. But a forest garden mimics the successional of a real forest, but puts in more yielding plants. So in a jungle, there are yielding plants. We just can't find them, and they're spread so far apart that it's difficult without knowledge of how to find them or locate them or use them. But in our forest garden, we're going to recreate the system of a forest, but with more yielding plants. So we say a designer forest. We're going to use polycultures. We're going to start to understand plant families. We're going to look at avocado, for instance, an avocado tree as a canopy, and under it I can have comfrey as a herbaceous layer. The comfrey is a dynamic accumulator, which will help me to bring minerals because it has a very long taproot. And also, I can call it living compost. The comfrey can be cut. I move the greens to my compost. The greens are going to have a high mineral content because of the long tap roots, and it grows back. Great plant. Okay, so think about in your thing, look up your location, climate, dynamic accumulators. So what are the dynamic accumulators in your climate? Elderberry sub canopies. Okay, so we're just going to start to learn about this. And if you look up guilds, permaculture guilds online, people have posted thousands of proposed guilds. So you look up the fruit tree you like, avocado guild. Boom, people have all kind of different ones that they've proposed. We can look at like currants. So if I'm a temperate climate, I could have currants as a shrub layer, and then I could have sunchoke as a rhizosphere. They would grow well together. Root, right? I could have purslane as a ground cover with passion fruit as a vine. So we start to see these relationships. We're things that grow together that help each other with management. For instance, the ground cover suppresses the weeds, facilitates improved and nitrogen fixation to the vine, so I get a higher yield. That's called accelerating succession. When I understand the relationships and the spatial time relationships, right, I can, as a designer, intervene in a system to increase the speed, to increase the time to get to climax of a forest. In a naturalized system, if I burn down a forest and I let it try to go to climax, it could take as long as 200 years. From a permaculture situation, I can walk in after that, right, forest fire, put in my legumes, and I can bring that up to climax in as little as 10 years. I can increase that time period because we have the assemblies of plants. We can place those, we can proceed chop and drop, and we can speed up succession. We're going to do that with perennial tree crops. We want to have trees that are perennial. They're going to last for long periods of time. Some of the fruit trees can go for 200 years, like jackfruit trees, okay, durian trees. These type of tree systems we want to try to incorporate, and nuts. If you're in a temperate climate, nuts are amazing. So think about what nuts will grow in your climate. Really great source of protein. Almost all of them are easy to store. Okay, so that's what we want to look for. The future of food in temperate climates is going to be nuts, guys. And they're not going out of style, and they're going to keep getting more expensive, especially if there's more people. So I would learn about nuts in a temperate climate. Farm the soil, not the plant, guys. First couple days, I'm really intense on the soil, right? Haven't walked in our garden once. Think that's funny? Think about it. You came to a permaculture course, didn't bring you in the garden yet. You know why? Plant's an output. Good soil, good plants. Plants are easy, bro. That's just an output of good soil. We get our soils right, we're not going to have pest problems. We get our soils right, we're going to have nutrition. We get our soils right, the plants, they're an output of good soils. So we farm the soil in permaculture, not the plant. We don't farm the problem. Remember, the problem is the solution? You got plant problems, you better work on your soil because the soil fixes all your plant problems. So humus is what makes that happen. What is humus? It's a stable carbon compound. We want to get a stable carbon compound, broken down organic matter that has reached a point of stability. We want to create humus. It's a stable organic compound. If we don't have that, like we don't here at Raktamachat, they cut down the rainforest and they burnt everything. I'm only left with clay. I have no humic material. So I have to build my stable compounds. That's why we make our chars. That's why we're making our compost. And that's why we're putting it in the right ratio and putting back in the effective microorganisms and the macrophytes, the worms, to rebuild that compound. Once my garden has a condition of that, the plant, it's easy. So soil building techniques. We can employ compost in your system. Where's your compost pile going to be, guys? Yeah? In the relationship for your design. Why do we want to have a compost pile? It recycles our waste. It speeds up the breakdown process. We're speeding up succession, and it gives us a biological inoculant for the soils in our garden. We're going to build up those beneficial microorganisms, and then we're going to boom that garden, and that plant's going to respond. This is why we want to do that. We're going to use cover cropping. What does that mean? Don't fight the weeds, guys. Grow the weeds. Weeds are great. They grow fast, rampantly. Good. I need compost, grow weeds. Put it in the compost. Right? These are the type of things. It's much better to have a cover crop than to have the sunlight evaporating all your water. You'll reduce the water usage. So if you have a cover species, you can utilize it. So don't think about fighting them all the time. Use them. So you got to find those beneficial weed systems that will work in your place. Look it up. People discuss it on the internet. So mulching. In certain instances, we need to control temperature or maybe impact, right? So we can feed soil microorganisms. We can regulate the temperature and the humidity of the soil, utilizing less water. And it also can protect from erosion if we have really big rainfall events like here in the tropics, just pounding. So I can stop that pounding by utilizing a mulch. Stop the impact, okay? Help me to stop the sun. Too much sun evaporates all my water. These are really good benefits. And at the end of the day, it breaks down, feeds the plant. We could look into chinampas, different types of broad-scale water harvesting systems. This is called a reconstructed wetland. A ditch and a mound, basically. It increases the land and increases the water availability, and it increases productivity. So as we saw on James's and their thing, they had their pond and they built their little chinampas. We also saw it on the other one in Australia, how they had their chinampa system. Here in Thailand, I wish I could do this, but I can't because we're in a wet, dry tropical, and our water table changes in the ponds by 3 meters a year. So I can't stabilize the water, but I can create an artificial chinampa. What is that? Permaponics. Yeah? I'm regulating the water level to create the wick, the same as what they did if they have a stabilized water system. So if you have stable or can control your water inflow, these work really well. And if you don't, that's all right. We have modern things like buckets and plastics and stuff, and we can do that. Swales. Swales are water harvesting ditches and mounds on contour. But one thing I want to say to you guys, that's really nice that she has that in her yard, and I assume she likes the shape of it because it's not doing anything. It's not harvesting any water. She used a hose to fill it up. But when it rains, maybe a little water gets in it. But we put these on slope. We need to utilize them to slow overland water flows. If the water is not actually flowing over land, then it's sinking in. So this would not sink in any more water than whether it just rained on the grass. So then the space for the ditch is non-utilized for, say, could have been vegetables. One of the more appropriate ways to do this in a garden setting, in a flat area, is to make the path the swale. I walk in the swale, that's my path, and I have 2 raised beds. When it rains, my path floods. If it rains too much, I can put mulch. I mulch the path, right? The bottom layer would flood and rot. At the end of the year, I take that mulch and I throw it onto my bed and I put new bark. So bark, the swale bed, which is actually the path because it's flat. So we'll talk about that more later when we do swaling, which I like to say is micro swales. So if you notice the schematic from the book, it's on a hillside. The water is running overland and they're slowing down overland water flow. If it's flat, there's no overland water flow. Okay? Just think about it. So broad scale water harvesting. That's what typically we see swales on broad scales. They take water from the hillside flowing down and they bring it to the dam. We store it in the dam, then downhill. Now that we have water stored, we can change the nature of that landscape. In these situations, when there's no water stored, only really first level successional grasses grow, and the only thing that can process those is herbivores. So the answer is put herbivores. But when we capture water, we can change the nature. We can grow horticulture, fruit trees, nut trees. We can grow vegetables, second level successional vegetables. They need much more water, and we have access. So when we put in our earthworks, we can change the nature of the landscapes, like that plan I showed you. Big cattle farm turned into a fruit or nut farm. How did that happen? We were able to capture the water utilizing the topography. So that's our earthworks day. We'll look in that. Or if we're in a desert situation, we can slow down the flash floods that kill people by using rocks to make basically speed bumps. So when the water comes, it hits the rocks, bam, slows down. And when it slows down, it drops to silts behind the gabions. And that makes a fertile place to grow. Urban permaculture, balcony gardens, right? You'd be surprised how much food you can grow in a balcony, and especially utilizing vertical techniques. Hanging things under on the walls, you've got the trellis. You can put in aquaponic systems, a little small reservoir, small fish, frog if you want, easily to circulate. Have your compost on one side, your aquaponic on the other, all thing of hanging. Hey man, you got some old pants, you can't fit them anymore? I know I'm getting there, drinking too much beer. So I take my jeans, because I have all these blue jeans from like the States. Now I don't ever wear blue jeans. I don't know if I'll ever wear blue jeans again. Cool, take your blue jean, tie a knot in the bottom, tie a knot, hang it onto your railing, fill it up with potting mix. Now make sure that you get really nice, I recommend the female blue jeans that have like those, you know, the whiter part. And then you put that, and then from down, it looks like there's a butt hang. I mean, just saying, think about it. Really nice potter, free. So secondhand blue jeans equal, yeah, just me. Okay, take some direct action possibly. I mean, I know I'm moving more into this. I'm on a different permaculture path than you guys are. I started before you. So now I have to start thinking in the future. I've kind of made my farm. Hell, man, I made a I made a permaculture education institute, and what's a little past that? It's taking a little bit more direct action, a little bit more getting involved, maybe having to leave Raktamachat, which I don't like to do. But if I did do it and I want to go out, I need to do more than just say something sometimes. So we can take direct action. Here, they went and they put a compost pile, which is a banana circle, right in the front of Parliament and said, hey, why isn't this so out here? Why isn't the government taking action for these type of things, like water harvesting, gray water reuse, okay? Direct action. Think about your community-supported agricultural systems. You know, find out the local grower in your area and support them. Buy a share at the beginning of the season, and you receive produce weekly. Products received can include meat, dairy, veggies, fruits, nuts, bee products, and flowers, whatever they happen to grow. And these type of growers, because they're basically helped with their cash flow, tend to grow a more diversified range. So they'll grow 20 or 30 different fruits and vegetables on their place instead of just one, because they have a cash flow helped by the and these are open, and you can go there to pick your own, or you can bring your kids to see where their food comes from, right? You know, we can buy organic sometimes at whatever Whole Foods and stuff, but man, try to go visit the place where it's grown, man. You're not allowed to go there, okay? Some corporation, they're not letting you in the gate. So we want, you know, support local growers, know who grows your food. Think about beyond organic. Beyond organic, what is that? I need to know where my food comes from. I want to know the actual grower. If you know, it's organic, but man, it's some big corporation. I'm just supporting that, you know, business cycle. I want to know the grower. This is our farmers markets. Get to know the people who grow your food. Think about your resilient energy systems. Are you looking for hydro, micro hydro? Are you going to be doing biogas? Do you want to do solar? You want to get a little windmill? Are you near a place that already has some type of renewable energy source? So if I'm in Germany, 80% renewable. Okay, well, that's cool. I'm in there. I'm going to support that because the government's behind it. But if I'm not in a place like that, I might have to do it on my own. So these are choices we have to make. Passive solar housing. Your house is important. I don't ever see too much where people draw their little house and they don't do much past it. A house needs to have functions just as well as the functions outside, guys. So take the opportunity to, yes, draw your square where it's going to be located, but take a page and make a map of your house. Describe what type you might want. How are you going to make your house passive solar? What type of materials are you going to use? You like super adobe, or you like adobe, or you like bamboo, or you like whatever you like, okay? That's up to you, but take that opportunity to start thinking about that. You may not build your house for another 5 or 10 years, but we need to start thinking about it now, so when it comes time to build our house, we'll have already done our due diligence. So a house should basically heat itself, cool itself, and catch its own water. We shouldn't have to pay for those things. It can do that itself.